My presentation is dedicated to a problem of the hidden faults considered for FPGA-based components of separately-related systems. The relevance of this problem is associated with several positions. High-risk facilities in energy and transport are becoming a natural environment for humans. They constantly increase the quantity, complexity, and power. In order to limit risks, it is necessary to develop information technologies introduced into safety-related systems. There are aimed at ensuring functional safety in both the system and the control object for preventing accidents and reducing the consequences. Functional safety based on fault tolerance solutions. But a fault tolerance system can be safe only if it is checkable. A lack of checkability creates a problem of the hidden faults. We know this problem from failed attempts to detect hidden faults using imitation modes aimed at recreating emergency conditions and repeatedly resulted in them due authorized activation by human or failure. The planned activation of such modes often includes the shutdown of emergency protections, which has become one of the causes of the Chernobyl disaster. This work is aimed at presentation of a method of the hidden faults opposition for FPGA-based components of safety-related systems. We suggest considering the following questions. Sources of the suggested method, main provisions of this method, case study, and conclusions. Sources of the suggested method. The resource-based approach, which considers the integration of the artificial world created by human into the nature one, defines three levels in the development of models, methods, and means: replication, diversification, and self-sufficiency as a development goal. This approach identifies a safety-related system as development of computer systems with diversification of an operating mode by its division into a normal mode and emergency one. A problem of hidden faults in the accumulation in digital circuits during a long normal mode and their manifestation in reducing fault tolerance of circuits with the beginning of the most responsible emergency mode. In hidden fault problem as growth challenge, when safety-related systems rise to a level of diversification in checkability that becomes different in normal and emergency modes for matrix circuits, but system components continue to be stamped at a lower level of replication using matrix structures. One of the most important directions in the development of digital components for critical systems is associated with FPGA designing. FPGA refers to programmable hardware that raises such stamped element matrix to the level of diversification, but using the natural version redundancy in program code of FPGA projects with load-oriented architecture. Natural version redundancy is considered for each pair of load units where output of the first load unit is connected to input of the second load unit. The load unit pair contains two program code versions, which differ from each other in direct or inverse value of the bit transferred from the first load to the second. Main provisions of the method. Classification of the hidden fault problem as a growth challenge determines the ways of its solution by raising the components to the system level. The method opposites to hidden faults of the short circuit between two neighboring inputs of the load unit. The method uses the synergy in several types of natural virtual redundancy in two essentially different modes of the safety-related systems, normal and emergency, in hidden fault elimination solutions by opposition to accumulation of faults during normal mode and their manifestation in emergency mode. In two fault states, its masking or error manifestation in the case of the same signal values as the neighboring input of the load unit and otherwise. In two important but contradictory parameters, the result transfer finesse and circuit checkability, connected with fault masking and manifestation. In two program code versions, changing the fault state. The method considers two sets of erroneous bits in the memory of the load units, a set of N bits addressed in normal or both modes, and a set of E bits addressed only in emergency mode. The method reduces amount of the hidden faults by choosing versions with non-empty set of N bits for improving the checkability of the FPGA project in the normal mode, and with the lowest number of E bits in case of empty N set of increase of the result transfer finesse in the emergency mode. The method performs the following steps: simulation of calculations executed in FPGA project with determination of the N and E bit sets in memory of each load unit. Determination of all possible faults of the short circuit between neighboring inputs of each load unit. Determination of all versions of the load program code for all possible faults and the N and E bit sets for each version. And selection of versions that reduces the number of the hidden faults in the normal and emergency mode. Case study of the method. Experimental verification of the method was carried out using cut quarters prime addition on the example of a study of a 4-bit iterative array multiplier implemented in Intel Max 10 FPGA chip. The digital circuit simulation was carried out using the program implementation of the method. The program was developed in the 3 Delphi 10 Seattle demo version. The main panel of program shows simulation results for 8 values of the threshold. The values of the factors smaller than threshold refer to the normal mode and the rest to emergency one. The first time line of simulation results shows the number of the best version for considered load unit. The next 3 lines evaluate the result transfer finesse to the initial, the best, and the least successful version of the load program code. The last line shows the gain in the transfer finesse of the best solution compared to the initial FPGA project and the least successful version. The transfer finesse of the results increased by 25%. Conclusions. FPGA designing opens up the new possibilities for solving the hidden fault problem inherent in safety-related systems as a growth challenge by raising the components to the level of diversification. The proposed method uses the synergy of several types of natural version redundancy, including one in the program code of FPGA projects with a load-oriented architecture to reduce the set of hidden faults when short-circuiting neighboring inputs of load units. The method reduces the number of hidden faults in 2 ways. The first way is to search for each load unit the program code versions showing a failure in the normal mode. The second way applies to load units for which there are no such version and choose the version with the least amount of erroneous values in bits addressed only in emergency mode. Thank you for attention.